Every photon you have ever emitted is still traveling. The light from the candles on your first birthday cake, the glow of every screen you have ever stared into, the faint warmth your body is radiating right now as you sit and listen. All of it is moving outward at the speed of light, and none of it is coming back. It is going somewhere, and physicists have a name for the place it is going. They call it Scri-Plus. Scri-Plus, written in the mathematics as a stylized script letter I with a small plus sign, is future null infinity. It is the boundary where every ray of light in the universe finally arrives, the conformal edge of space-time itself. You could never visit it. To reach it, you would have to travel at the speed of light forever. And yet, a generation of physicists now argue that this unreachable edge may be the most important surface in all of reality, a holographic plate onto which the entire history of the cosmos is being permanently, silently written. In the time we spend together, you will see where the future actually stops. The infinite symmetry hiding at the edge of space-time. The soft particles that may carry a black hole's lost memory. The permanent scar every gravitational wave leaves behind. And why this boundary may be exactly where the block universe, the idea that all of time already exists, finally ends. If you find value in explorations like this, the subscribe button quietly helps these deep dives reach more curious minds. So, here is where it begins. To understand Scri-Plus, we have to begin with a problem that sounds almost childish. Where does the universe end? Not in the sense of how big it is, but in a deeper sense. If you are a ray of light traveling outward through empty space, where do you finally arrive? Forever is not an answer a physicist can write equations about. Infinity is not a place. You cannot put it on a map. You cannot integrate over it. You cannot ask what happens there, because there is no there. For most of the history of physics, infinity was the spot where the mathematics stopped and the hand-waving began. Then, in 1963, an English mathematician named Roger Penrose did something quietly radical. Penrose found a way to take infinity, the unreachable and the endless, and pin it onto the edge of a finite picture. The technique is called conformal compactification, and the idea behind it is one of the most elegant in all of theoretical physics. You take the true metric of space-time, the thing that measures real distances and real durations, and you multiply it by a carefully chosen scaling factor. As you move toward infinity, that factor shrinks towards zero, squeezing the endless distances into a finite region. What was unreachably far away becomes a clean boundary you can draw with a pencil. Penrose's rescaling can be written simply. The new rescaled metric equals omega squared times the true metric. G tilde equals omega squared G, where omega is the scaling factor, a number that smoothly approaches zero exactly at infinity. Where omega hits zero, you have reached the edge. You have reached Scri. Think of what a cartographer does to the round Earth. The planet has no edge. You can walk forever and never fall off. But a map maker can take that endless surface and render it on a flat, finite page, with the poles stretched into lines along the top and the bottom. Nothing real has been lost. The infinite has only been redrawn, so the human eye can hold all of it at once. Penrose did this for the entire universe. He drew space-time as a finite diamond, and around its edges he placed the different flavors of infinity. And there are several flavors. This is the part that surprises people. Infinity is not one place, it is many. If you are a massive object, a planet or a person or a star, and you wait, drifting forward through time forever, you eventually arrive at a single point at the top of the diagram. Physicists call it future time-like infinity, written I+. Trace any object back to the infinite past, and it emerges from a single point at the bottom, past time-like infinity, I-. Off to the side, infinitely far away in space at a single instant, sits spatial infinity, I-0. But light does not go to any of these. Light is different. Light travels along the diagonal edges of the diagram at 45 degrees, and it arrives at its own special boundary, the slanted surfaces that form the sides of the diamond. Outgoing light, light racing toward the future, lands on future null infinity. Scri-Plus. Incoming light, arriving from the infinite past, comes from past null infinity, Scri-. Picture the diagram as a tall diamond standing on one point. The top vertex is the destiny of everything with mass. The bottom vertex is its origin. The left and right points are spatial infinity, and the four slanted edges connecting them, those clean diagonal lines, are where all the light in existence begins and ends. Every star you can see in the night sky is pouring its light along those diagonals, and every one of those photons is bound for the same address, the upper edges of the diamond, Scri-Plus. This is not a metaphor the physicists invented for the public. It is the literal geometric structure of an idealized, asymptotically flat universe. A universe that becomes empty and gravity-free as you move far from any matter. Brandon Carter refined Penrose's drawings into the diagrams we still use today, the ones now named after both of them. And on every one of those diagrams, Scri-Plus is the surface where the future of all light is recorded. Keep that word in mind, recorded. We will return to it many times, and each time it will mean a little more. A boundary is only interesting if something happens there. And here is where the story turns from geometry into something far stranger. Because in the very same era that Penrose was learning to draw infinity, another physicist was discovering that the edge of space-time has a symmetry, a hidden structure so large that it dwarfs everything we thought we knew about the symmetries of the universe. His name was Hermann Bondi. Born in Vienna in 1919, he was an Austrian-British cosmologist, a sharp and combative mind who had already helped invent one of the great rival theories of cosmology. But the work he would come to value most came in 1962. Working with two collaborators, Vanderburg and Metzner, and in parallel with the mathematician Rainer Sachs, Bondi set out to settle a question that had haunted Einstein's theory for decades. Do gravitational waves carry energy? Are they real, physical things that drain power from their source? Or are they only mathematical ripples in the coordinate system, illusions that a clever change of perspective could erase? To settle it, Bondi and Sachs studied how gravity behaves far from its source, out near null infinity, near Scri-Plus, where the waves would finally arrive. And what they found there was a formula, clean and brutal and decisive. The mass of an isolated system, measured at the boundary, is not constant. It bleeds away. They wrote it as a rate of change, the change of what is now called the Bondi mass, with respect to retarded time, equals the negative of the gravitational wave energy flux escaping to infinity. In speakable form, the rate at which the system's mass decreases equals the integral over the whole sphere at infinity of the square of a quantity called the news function. The news function is exactly what it sounds like. It is the part of the gravitational field that carries news, real information, real energy radiating outward. When the news is zero, nothing is happening. When the news is non-zero, the system is broadcasting, and it is paying for that broadcast with its own mass. This was the proof. Gravitational waves are real. They carry energy away from their source, permanently, and that energy flows out to Scri-Plus and is gone. Bondi never forgot what he had done. Decades later, he wrote that the 1962 paper was, in his words, the best scientific work he had ever done. And he noted, dryly, that it had come later in life than mathematicians are supposed to peak. There is something worth sitting with in that. The deepest thing this man discovered, he discovered after the age when his field told him his best years were behind him. For over 50 years, the Bondi-Sachs mass loss formula was a theorem on paper. Then, on the 14th of September 2015, it became a measurement. Two enormous laser instruments in the United States, the LIGO detectors, each with arms 4 kilometers long, about 2.5 miles, caught a signal. Two black holes, one 36 times the mass of our Sun, the other 29, had spiraled into each other 1.3 billion light-years away and merged into a single black hole of about 62 solar masses. Notice the arithmetic. 36 plus 29 is 65. The remnant was 62. 3 solar masses had simply vanished, converted entirely into the energy of gravitational waves and radiated away to infinity, exactly as the Bondi formula demanded. For a fifth of a second, that collision radiated more power than every star in the observable universe combined. Not more light. Light had nothing to do with it. It was pure gravity, pure space-time, screaming outward toward Scri-Plus. And the instruments that caught it had to measure a change in their 4-kilometer arms smaller than 1/10,000th the width of a proton. It is like measuring the distance to the nearest star beyond the Sun and resolving a change the width of a single human hair. What does it mean that 3 suns can disappear and the only trace they leave is a ripple heading for the edge of space-time? Hold that question. We are only beginning to build. It is worth pausing on the question of what a boundary in space-time even looks like, because we have in fact photographed one. Not Scri-Plus, that can never be imaged, and we will come to why. But a black hole's boundary, its event horizon, is in some ways an inner cousin of the great outer boundary at infinity. And in 2019, humanity saw one for the first time. On the 10th of April that year, the Event Horizon Telescope released the first image ever made of a black hole, the supermassive giant at the heart of the galaxy M87, a monster of 6.5 billion solar masses, sitting some 53 million light-years away. To resolve something that small at that distance, astronomers had to turn the entire Earth into a single telescope, linking radio dishes across 6 locations around the planet into one instrument the size of the world, with a resolution fine enough to read a newspaper in another city. What came back was a ring, a bright, glowing circle of superheated gas and bent light, about 40 micro-arc-seconds across, wrapped around a region of perfect darkness, the shadow of the hole. The image was beautiful, and it was also a lesson in the nature of boundaries. Here is what the picture is not. It is not a photograph of the event horizon. You cannot photograph an event horizon. It emits nothing. What the Event Horizon Telescope captured was the lensed ring of light just outside the boundary. The last orbits of photons skating along the edge of the abyss before plunging in or escaping outward. The boundary itself reveals its presence only by its silhouette, by the darkness it carves into the light around it. We see the edge by seeing everything except the edge. Hold on to that, because it is the pattern of this entire subject. The most important surfaces in physics are the ones we can never directly see, the ones that announce themselves only through what gathers at them and what flows toward them. The event horizon shows itself as a shadow. Scri-Plus shows itself as the destination of all light, the ledger where all radiated energy is filed. Neither is a wall you could touch. Both are boundaries written into the geometry of reality itself. And both, as we will see, are now suspected of being far more than empty edges. They are suspected of being records. So, 3 vanished suns leave nothing behind but a ripple bound for the edge of space-time, where the ripple joins the permanent account of everything that has ever happened. Sit with that as the structure deepens. The BMS discovery, named for Bondi, Metzner and Sachs, contained something even Bondi did not fully appreciate at the time. When they catalogued all the symmetries that survive out at null infinity, all the transformations you can perform on the boundary without changing the physics, they expected the familiar set. The Poincaré symmetries, the 10 transformations of special relativity, translations in space and time, rotations, and the boosts that mix space and time together. Einstein's symmetries, the bedrock of modern physics. They expected those 10 and nothing more. Instead, they found infinity. The symmetry group at the edge of spacetime is not the Poincare group. It is larger, vastly and impossibly larger. It contains the familiar rotations and boosts, but in place of the 4 simple translations, it contains an infinite-dimensional family of transformations called supertranslations. A supertranslation is a strange thing. It is a shift in retarded time, a shift in the clock that can be different at every single point on the sky. You can slide time forward more at the north pole of the celestial sphere than at the equator, less here than there, following any pattern you like across the heavens. Written as an equation, it is almost insultingly simple. Retarded time u becomes u minus f, where f is an arbitrary function on the sphere, any function at all. Each choice of that function is a distinct symmetry of the edge of the universe. There are infinitely many of them. The standard way to say it is this: the BMS group is the semi-direct product of the Lorentz group with an infinite-dimensional group of supertranslations. Later work showed it goes further still, extending the rotations into objects called superrotations, which bring in the deep mathematical structure known as the Virasoro algebra, the same structure that sits at the heart of string theory. The edge of space-time, it turned out, is not a quiet place with a handful of symmetries. It is a place of infinite symmetry, infinitely rich, and we had been walking past it for half a century without looking. Think of an ordinary translation, the symmetry that says the laws of physics are the same here as they are a meter to your left. Slide the whole universe over by a fixed amount and nothing changes. That is one of the bedrock symmetries Einstein built upon. A supertranslation takes that humble idea and lets it run wild. Instead of sliding everything by the same fixed amount, you slide the clock forward by a different amount in every direction of the sky, a little here, more there, following any pattern you can draw on a sphere. It is as if, instead of one rigid shift, the universe permitted an independent shift for every star in the heavens, all at once, and still came back unchanged. Where ordinary physics had 4 ways to translate, the boundary has infinitely many. The symmetry of the edge is not a slightly larger version of the symmetry we knew, it is an ocean where we had seen a cup. This carries a consequence so strange it took physicists decades to take it seriously. If there are infinitely many supertranslation symmetries, then there are infinitely many distinct states of empty space. The vacuum, true and empty and gravity-free, is not unique. There is not one nothing. There are infinitely many different nothings, each related to the others by a supertranslation, each with exactly 0 energy, and yet each genuinely, physically distinct. Empty space is infinitely degenerate. The universe had to settle into one of these infinitely many vacua. We will return later to what that means and to the question of what exactly does the settling. For now, notice the shape of what we have found. The edge of space-time is real. It can be drawn. It has a name. Energy flows to it and is recorded there. It carries a symmetry larger than anything in ordinary physics. And it forces empty space itself to choose, from an infinite menu, which version of nothing it will be. These are the foundations. Everything that follows is built on them. There is a way to feel the reality of the supertranslation vacuum, to see that it is not bookkeeping but a physical fact about the world. It is called the gravitational memory effect, and it is one of the most beautiful and unsettling predictions in all of general relativity. The story begins in 1974 in the Soviet Union. Two physicists, Yakov Zeldovich, one of the towering figures of 20th century science, and his colleague Boris Polnarev, asked a simple question. When a gravitational wave passes through a region of space, what does it leave behind? The textbook answer was nothing. A wave is a ripple. It passes, the water settles, and the pond returns to exactly how it was. Zeldovich and Polnarev found that this is wrong. After a gravitational wave passes through a collection of free-floating test masses, the masses do not return to where they started. Their positions are permanently changed. The wave moves on, but it leaves a scar. Imagine a ring of small beads floating freely in space, far from anything, perfectly still relative to one another. A gravitational wave from some distant catastrophe sweeps through. As it passes, the ring stretches and squeezes, distorting into an ellipse one way, then the other, oscillating as the wave goes by. And then the wave is gone. But the beads do not return to their original ring. They settle into a new arrangement, slightly displaced from where they began, and they stay there. The space between them has been permanently altered. This is displacement memory. The mathematics describes it as a permanent change in the strain of the metric, a change that corresponds exactly to a supertranslation. The passing wave has shifted the region from one BMS vacuum to another. The infinite degeneracy of empty space, the abstract thing we met a moment ago, is the very thing that makes memory possible. The two are the same fact seen from two directions. In 1991, the Greek mathematician Dimitrios Christodoulou, a student of John Wheeler at Princeton and one of the most formidable relativists alive, discovered that the effect is even larger than Zeldovich and Polnarev had calculated. There is a second, non-linear contribution arising from the energy of the gravitational waves themselves. The waves carry energy. That energy gravitates, and that gravitation adds its own permanent displacement. This is now called the non-linear or Christodoulou memory. It means the gravitational waves passing through you are not only carrying energy to Scri-Plus, they are rewriting the geometry of the space they pass through, and leaving that rewriting behind permanently forever. Here is the part that should give you pause. Right now, gravitational waves from countless distant mergers are passing through your body. They are far too weak to feel. But, according to Christodoulou's mathematics, each one leaves behind a permanent microscopic displacement, a tiny, indelible mark. The atoms of your body have been very slightly, very permanently rearranged by the death of black holes you will never see, billions of light years away. The universe keeps no eraser. Every wave writes and nothing unwrites. We have not yet detected gravitational memory directly. It is extraordinarily difficult. Memory is a permanent offset, a so-called DC change, a shift that stays. And LIGO, by its very design, is built to sense oscillations, not permanent shifts. To find memory, physicists must add up the faint accumulated traces across many, many detections. The forecasts are specific. Advanced LIGO at full sensitivity might reach a confident detection of memory after roughly 35 events like the first one, and a strong detection after about 90. Estimates suggest that as the detectors are upgraded, the permanent displacement memory could be measured after about 2.5 years of total observing time. We are close. Within this decade, we may hold direct evidence that the passing of a gravitational wave changes the universe forever. And there is a far larger instrument coming. LISA, the Laser Interferometer Space Antenna, will not be built on Earth at all. It will be 3 spacecraft flying in formation through deep space, trailing the Earth around the Sun, connected by laser beams across arms 2.5 million kilometers long. That is more than 1.5 million miles, more than 6 times the distance from the Earth to the Moon. And the lasers must hold that distance stable to within the width of a single atom. LISA was formally adopted by the European Space Agency in January of 2024, with a launch planned for the middle of the next decade. Its technology was already proven by a smaller mission, LISA Pathfinder, which launched in December of 2015 and demonstrated that a test mass could be left to float in perfect freefall, untouched by any force but gravity itself. When LISA flies, it will listen to the slow gravitational waves of merging giant black holes, and it may read the memory they leave on Spacetime with a clarity Earthbound detectors can only approach. This is the part that stays with me. Not the scale of the instruments, though 3 spacecraft holding formation across 1.5 million miles is its own kind of marvel. What stays with me is the permanence. Most of what happens in the world is undone. The wave on the pond flattens. The footprint in the sand is smoothed by the tide. The heat of a fire disperses and is forgotten. But gravitational memory is not undone. The displacement it leaves is a true, permanent change in the relationship between things, a mark that the universe makes and then never erases. Every massive event that has ever shaken space-time has signed its name, faintly and forever, in the geometry around you. What does it mean that the cosmos forgets nothing, that it keeps, in the very spacing of its atoms, an indelible account of catastrophes you will never witness, in galaxies you will never name? We tend to assume that the past is gone, that what has happened recedes into nothing, leaving only memory and decay. The physics of the boundary suggests something stranger and more sober. It suggests the past is not gone at all. It is recorded. The energy of every merger streams outward and is filed at Scri-Plus. The permanent scar of every wave is written into the bulk. The information of everything that falls into a black hole may be inscribed, soft and unreadable, on a holographic plate at its horizon. What does it mean that we live inside a universe that appears to be keeping perfect records? A universe that, whatever else is true of it, does not seem built to forget. A record implies something recorded, and a record kept this faithfully, in a place no creature could ever go to read it, invites a question we will have to face directly before we are done. For whom is the account being kept? So the picture deepens. Scri-Plus is where the energy goes. Memory is the permanent record left in the bulk, in the space we inhabit, as that energy passes through on its way to the edge. But now we come to the idea that took this entire field and turned it from a quiet corner of mathematical relativity into one of the most active frontiers in physics. The idea that the edge of space-time might solve the deepest paradox about black holes. The idea its discoverers call soft hair. To understand it, you have to understand the paradox. In the mid-1970s, Stephen Hawking showed that black holes are not perfectly black. They glow very faintly with what we now call Hawking radiation. The temperature of that glow comes from a famous formula. The Hawking temperature is inversely proportional to the black hole's mass. Small black holes are hot. Enormous ones are deathly cold. And because they radiate, black holes slowly evaporate. Over almost unimaginable spans of time, a black hole bleeds away its mass into faint thermal radiation, and eventually it is gone. Here is the catastrophe. That radiation, Hawking calculated, is thermal, featureless, random, carrying no detailed information about whatever fell into the black hole. So imagine you throw an encyclopedia, or a star, or a person into a black hole. The black hole evaporates over eons into structureless radiation. The information that made up that encyclopedia, that star, that person, where did it go? If it is truly gone, then the universe has destroyed information, and that violates one of the most sacred principles in all of physics. The present always contains, in principle, a complete record of the past. The equations of quantum mechanics are not supposed to allow forgetting. Yet a black hole seems to forget everything. This is the black hole information paradox. And for nearly 50 years it has been, in the words of one review, one of the most open problems in all of quantum gravity. To feel the full force of the paradox, you have to know two things that came before it. The first is the no-hair theorem. Classical general relativity insists that a black hole, once it settles down, is almost insultingly simple. No matter what you make it from, a collapsed star, a mountain of encyclopedias, a cloud of antimatter, the finished black hole is described completely by just three numbers: its mass, its electric charge, and its spin. Everything else is gone. Two black holes of the same mass, charge, and spin are identical, indistinguishable, no matter how wildly different the things that formed them. Physicists summarize this by saying a black hole has no hair, no extra features, no individuality, no memory of its origins. That word, hair, is exactly the word the soft hair physicists would later resurrect, and the choice was deliberate. They were claiming the black hole has hair after all. The second thing is the entropy. In the early 1970s, Jacob Bekenstein and then Stephen Hawking discovered that a black hole has an entropy, and that this entropy is proportional not to its volume, as you might expect for any ordinary object, but to the area of its horizon. The formula is one of the most quietly revolutionary in all of physics. The entropy equals 1/4 of the horizon's area, measured in fundamental Planck units. Entropy is, loosely, a measure of hidden information, the number of microscopic arrangements consistent with what you see from outside. And the fact that a black hole's hidden information scales with its surface area, not its volume, is the original seed of the entire holographic idea. It is as if everything a black hole contains is written on its boundary, like a message on the surface of a sealed envelope, rather than stored in the space within. A three-dimensional interior encoded on a two-dimensional surface. The boundary, once again, doing the work of the bulk. Now put the pieces together, and the paradox sharpens to a point. The no-hair theorem says the black hole forgets. The entropy area law says its information lives on the boundary. Hawking radiation says the black hole slowly evaporates into featureless thermal glow. So, does the information come back out with the radiation, written somehow on that boundary, or is it erased forever when the hole vanishes? The physicist Don Page sharpened the question into a precise prediction. If information is preserved, then, as the black hole evaporates, the entanglement between the black hole and its escaping radiation should rise, peak, and then fall back to zero by the time the hole is gone. This is the curve now called the Page curve. If Hawking's original calculation were right, that curve would rise forever and never come down, and information would truly be lost. In recent years, new calculations have begun in certain idealized models to reproduce the Page curve that preserves information. But how that works in a realistic universe, in our universe, is exactly where the boundary structures we have been studying are supposed to come in. And it is exactly where, as we will see, the honest physicists admit they are still in the dark. Now recall what we learned. The horizon of a black hole, like Scri-Plus, is a boundary. And boundaries, we have seen, carry the infinite BMS symmetry. In 2016, 3 physicists, Stephen Hawking himself near the end of his life, together with Malcolm Perry and Andrew Strominger, proposed that the resolution to the paradox might lie exactly there. Their paper was called Soft Hair on Black Holes, and its claim was startling. The supertranslation symmetries, they argued, require black holes to carry what they called soft hair. An enormous number of soft particles, soft gravitons, and soft photons, particles of essentially zero energy clinging to the horizon. Let me read you their own words, because they are precise. They wrote that their paper gives an explicit description of soft hair in terms of soft gravitons or photons on the black hole horizon, and shows that complete information about their quantum state is stored on a holographic plate at the future boundary of the horizon. A holographic plate. There is that idea again, the boundary as a recording surface. The old picture said a black hole has no hair, no features, nothing but mass and charge and spin. The soft hair proposal says the opposite. The black hole is covered in a vast, soft, low-energy fuzz, and that fuzz remembers. The information that fell in is not destroyed. It is encoded in zero-energy particles on the boundary, written onto a holographic plate. And the same logic that applies to the horizon applies ultimately to Scri-Plus itself, the great outer boundary where the radiation finally arrives, carrying its encoded history outward to the edge of everything. This was one of the last ideas Stephen Hawking worked on. His final scientific paper, Black Hole Entropy and Soft Hair, written with Perry, Strominger and Sasha Hacko, was completed and published in 2018, after his death in March of that year. There is something fitting and something heavy in that. A man who spent his life on the question of what black holes destroy, working to the very end on the possibility that they destroy nothing at all, that everything is kept, recorded somewhere on a boundary. His last word on the subject arrived, in effect, from beyond. The reason this idea electrified physics is that it connected to a structure of breathtaking elegance, something Strominger came to call the infrared triangle. 3 discoveries made decades apart by people who never imagined they were studying the same thing turn out to be 3 faces of a single piece of physics. The first corner is the BMS asymptotic symmetries we have already met, the infinite symmetry of the boundary. The second corner is a set of results called the soft theorems, proven by Steven Weinberg back in 1965, about how particles of very low energy behave in any scattering process. The third corner is the gravitational memory effect, Zeldovich, Polnareff, Christodoulou. 3 separate fields, 3 separate generations. And Strominger, working with Alexander Zhiboidov and others around 2014, showed they are mathematically equivalent. The symmetries are related to the soft theorems by what are called Ward identities. The symmetries are related to memory by vacuum transitions. And memory is related to the soft theorems by a Fourier transform. Pull on any one corner and the other 2 move. They are one structure wearing 3 masks. The symmetry of the edge, the behavior of soft particles, and the permanent scar in space-time are the same truth told 3 ways. And then the field took its most audacious step of all. If the boundary carries this infinite symmetry, and if the symmetry organizes all of physics, then perhaps the boundary is not merely a place where physics is recorded. Perhaps the boundary is where physics actually lives. This is the program called Celestial Holography, and it has become, over the last several years, one of the most ambitious projects in theoretical physics, backed in 2023 by an $8 million collaboration assembled specifically to pursue it. The claim of celestial holography is this: take the entire four-dimensional universe, all of its particles, all of its scattering, all of its complicated quantum dynamics. The celestial holographers propose that all of it can be re-encoded as a two-dimensional theory living on the celestial sphere, the sphere of directions at null infinity, which is, quite literally, the night sky. The two-dimensional theory is a conformal field theory, a type of theory physicists understand deeply. And the dictionary that translates between the four-dimensional world and the two-dimensional sky is built from a mathematical tool called the Mellin transform. The celestial amplitude is defined by Mellin transforming each particle's energy, converting the ordinary momentum description of a particle into a description based on how it transforms under boosts. In the four-dimensional world, the symmetries are the Lorentz transformations of special relativity. On the two-dimensional sky, those exact same symmetries reappear as the conformal symmetries of the sphere, the group the mathematicians call SL2C. The bulk soft theorems become symmetry statements, ward identities of the theory on the sky. This is holography in its purest, most vertiginous form. A four-dimensional universe fully described by a two-dimensional surface at its edge. One of the leading architects of this program is Sabrina Gonzalez-Pasterski, an American physicist born in 1993 who earned her doctorate at Harvard and now leads a celestial holography initiative at the Perimeter Institute. She co-discovered an effect called spin memory and helped complete the very triangle we just described, work cited by Hawking himself in the Soft Hair paper. The boundary in her field's vision is not the edge of the story, it is the whole story written small. What does it mean that the deeper physicists look into the structure of reality, the more it behaves like a message being recorded and the less like an accident running down? I want to be honest about how unfinished this picture is, because the honesty matters enormously for what comes later. Celestial holography is dazzling, and it is also riddled with deep, unresolved problems, and its own practitioners are the first to list them. The two-dimensional theory on the sky is not a normal, well-behaved conformal field theory. It appears to be non-unitary, meaning roughly that probabilities in the usual sense do not add up the way they must in a sensible quantum theory. It suffers from what the field calls, only half-jokingly, a C=0 catastrophe, a problem with a fundamental quantity called the central charge. It shows the strange logarithmic structure of an exotic class of theories that physicists still struggle to make full sense of. This is not a finished cathedral. It is scaffolding and brilliant guesswork and a conviction that something true is hiding underneath. That conviction may well be right, but conviction is not proof, and a research program full of open problems is not a completed account of reality. Remember that, because in a little while, someone is going to tell you this physics is complete enough to make God unnecessary. and you will want to recall what its own architects say about how much they still do not understand. There are facts in this subject so strange they are worth stating plainly, to feel how foreign the edge of space-time really is. Empty space is infinitely degenerate. There are infinitely many distinct states of pure nothing, all with zero energy, differing only by supertranslations. You can take a black hole and supertranslate it by throwing in a carefully shaped pulse of gravitational radiation. And the result is mathematically a sibling of the original, identical in mass, and yet, in the bookkeeping of the boundary, genuinely a different object. The extended symmetry, the super-rotations, drags in the Virasoro algebra, the same infinite mathematical structure that governs the vibrations of strings in string theory, as though the night sky itself were a kind of vast two-dimensional resonator. And a gravitational wave, after it has passed, never lets the space it crossed return to exactly what it was. The vacuum keeps the dent. None of this is science fiction. All of it sits in the peer-reviewed literature. The universe, examined at its boundary, is far stranger than the tidy three-dimensional space of our intuition. And the strangeness is not noise, it is structure. It is the kind of intricate, layered, mathematically exquisite order that, the deeper you look, the harder it becomes to imagine arriving by accident. Before we go on, let me ask you to do something. Pause for a moment on the sheer quantity of precise structure we have uncovered. Infinite symmetries, conserved ledgers, holographic encodings, permanent records. Then ask yourself, honestly, does this look like the debris of an explosion? Or does it look like the architecture of a design? Hold your answer lightly for now. We are not finished gathering evidence. But notice what your own mind reaches for when it sees order this deep. Now hold all of this together, because we are about to make the turn that gives this video its name. We have a boundary, Scri-Plus, where all light and all radiated energy ultimately arrive. We have a growing body of theory suggesting that this boundary is a holographic plate, a complete and permanent record of everything that happens in the universe. Every event, every photon, every gravitational wave, writing its history onto the edge of space-time, where it remains, finished and unchangeable forever. And that word, forever, pulls us into the deepest question of all. If the complete record of all history already exists, finished, at the boundary of time, then in what sense is the future still open? In what sense does time pass at all? There is a view of time, held by a great many physicists, called the block universe, or eternalism. It says that the flow of time is an illusion. Past, present, and future all exist equally and eternally as a single, fixed, four-dimensional structure, a block. Your birth, this moment, your death, all of them simply are, laid out in the block like cities along a road that exists whether or not you are driving down it. The feeling that now is special, that time moves, that the future is not yet real, all of that, the eternalist says, is a trick of consciousness, a stubborn local illusion. The primary reason physicists take this seriously comes from Einstein's own relativity. In special relativity, Observers moving differently disagree about which events happen at the same time. There is no universal now. And if there is no universal now, the argument goes, then perhaps all moments are equally real. Einstein himself seemed to believe it. When his lifelong friend Michele Besso died, Einstein wrote to Besso's family a line that has echoed ever since. He wrote that for those who believe in physics, the distinction between past, present and future is only a stubbornly persistent illusion. Besso had died a little ahead of him, Einstein wrote, and that, he said, means nothing. It is worth pausing to feel how this idea reaches into an ordinary life, because the block universe is not only a claim about physics, it is a claim about you. If eternalism is correct, then this moment, the one you are living right now, listening to these words, is not uniquely real. It does not have some special status called the present that the moment of your birth has lost and the moment of your death has not yet gained. All three exist with equal standing, fixed points in a four-dimensional structure that simply is. You are not moving through your life. Your life is a shape, complete. And the sensation of moving through it is, on this view, a feature of how consciousness is arranged, not a fact about time. The proponents of this picture are not cranks. They are sober physicists and philosophers. And they hold it because the relativity of simultaneity genuinely does dissolve the universal now that common sense takes for granted. What does it mean that the most successful theory of space and time we have ever written seems, on one reading, to erase the very flow of time we feel most certain of? And here, the physics of Scri-Plus seems to hand the eternalist a gift. If the complete history of the universe is already inscribed on a boundary at the end of time, if the final ledger is, in the timeless language of the mathematics, simply there, then the block does not need to be argued for philosophically. It looks as though it has been built into the geometry. The future is not a fog waiting to condense. It is a page already written in an account already closed. The boundary is the back cover of the book. And if the back cover already exists, then so does every page before it. The future is not being created, it is being read. This is the claim in its strongest form. Scri-Plus is the mathematical boundary where the block universe ends. The final page that proves the whole book was always already there. I have presented this fairly because it deserves a fair hearing, and because many brilliant and sincere people hold it. But notice what has quietly happened. We began with geometry and gravitational waves, neutral and careful science. And we have arrived at a set of claims that reach far beyond physics. That time does not pass, that the future is fixed, that the record is complete and needs no author. Those claims we have not yet tested. We have only presented them. Keep them in mind. The numbers we have seen, and the assumptions hiding beneath these grand conclusions, we are about to examine with very different eyes. For everything we have built so far, I have played the reporter. I laid out what physicists have found and what they argue, fairly and without objection. That was deliberate. You needed to see the structure clearly before we test whether it can hold the weight that has been placed upon it. Because a great deal of weight has been placed upon it. Around the elegant mathematics of Scri-Plus, a set of much larger claims has grown. Claims not about geometry, but about God and purpose, and whether the universe needs any explanation outside itself. Those are the claims we will now cross-examine, not the physics. The physics is sound. The philosophy that has been smuggled in alongside it, that is what we will hold up to the light. Let us start with the grandest claim of all. It runs like this. The universe needs no creator because the physics is self-contained. Information is conserved. It is encoded on boundaries, on the horizon, on Scri-Plus, on the holographic plate. The laws close the loop. Everything is accounted for within the system, and a complete mathematical description of nature leaves nothing for a creator to do. The universe, on this view, explains itself. It is a powerful sounding claim. Let us examine it honestly, and let us begin on its own terms, with the testimony of the very people who built the theory. Here is the first problem, and it is devastating, because it comes not from a critic, but from the field's own leading architect. The whole picture, soft hair, holographic plates, the universe encoded on its boundary, rests on the holographic principle. The idea that the contents of a region can be fully described by information on its edge. The trouble is that the holographic principle has only ever been made to work rigorously in a specific kind of universe. A universe with a particular curved geometry called anti-de Sitter space. A universe with a wall around it. That is not our universe. Ours is, as far as we can tell, asymptotically flat, and it is expanding. And for a universe like ours, Andrew Strominger, the man at the center of soft hair and celestial holography, as central a figure as this field has openly admitted that we do not know how to formulate the holographic principle at all. In his words, applying or even formulating the holographic principle for the kind of space we appear to live in is, and I quote, one of the huge problems in physics. Not a solved problem, not a problem of filling in details, a huge open problem. Sit with that for a moment. The argument was that the physics is complete, so no creator is needed. But the physics is not complete. By the explicit admission of its own founder, the central principle on which the whole edifice rests has not even been written down for the universe we actually inhabit. The claim of completeness is not a discovery, it is a promissory note, an IOU written against a theory that does not yet exist. And the trouble runs deeper than one unsolved problem. Recall the soft hair proposal, the beautiful idea that black holes store their lost information on a holographic plate of soft particles. It is genuinely beautiful. But does it actually solve the information paradox? Two physicists, Raphael Bousso and Massimo Porrati, examined it carefully in 2017 in a paper with a pointed title, Soft Hair as a Soft Wig. Their conclusion was blunt. The soft, long wavelength particles in question, they showed, simply pass through any interaction without engaging it. They scatter trivially. And so, in their exact words, the large-gauge symmetries bear no relevance to the black hole information paradox. The hair is there, but it is not doing the job it was hired to do. And even among physicists more sympathetic to soft hair, the consensus in the review literature is that the deeper problem, how you would ever extract the stored information, remains entirely unsolved. The record may exist. No one has the slightest idea how to read it. So what exactly is the claim that the universe needs no creator actually standing on? It is standing on a principle not yet formulated for our universe, a mechanism that critics show is irrelevant to the paradox it was meant to solve, and a stored record no one knows how to recover. This is not a closed case. This is a construction site with a banner hung over it reading, "Completed." Now, I want to be precise and fair, because this is where careless thinking does real damage. Even if the physics were complete, even if every equation was solved tomorrow, it would still not deliver the conclusion the materialist wants. To see why, we have to notice a confusion buried in the very word "explain." A complete description of how the universe behaves is not the same as an explanation of why there is a universe at all. The two are different in kind. Consider the difference this way. Suppose you possessed the perfect blueprint of a house. Every beam, every wire, every dimension specified to the millimeter. A description so complete that nothing about the structure was left unknown. Would that blueprint explain why the house exists? Would it tell you that someone wanted shelter, bought the land, paid the builders? Of course not. The blueprint describes the house. It is silent on the question of why there is a house rather than an empty lot. You could study that blueprint for 1,000 years and never find, anywhere in its lines, the decision that brought the house into being. The description lives entirely inside the house. The explanation lives entirely outside it. The laws of physics are the blueprint. They are a magnificent, intricate description of how the contents of reality behave. But a law is not a cause. A conservation law tells you that a certain quantity does not change. It does not tell you why there is any quantity there to be conserved, or why there is a universe in which conservation can occur. The holographic plate at Scri-Plus may record everything that happens. It does not, and it cannot, record why there is anything to happen to. The materialist points at the completeness of the description and says nothing is left to explain. But the deepest thing has been left untouched. It has, in fact, been quietly assumed at the very start: the existence of the structure itself. Ask the question directly. Why is there a Scri-Plus at all? Why is there a universe with a boundary on which to write its history? To that question, the equations are silent. They were always silent. They describe the writing. They say nothing about why there is a page. This is the question materialism cannot answer, and you can watch the evasions begin every time it is asked. Why is there something rather than nothing? Press the point, and you will be told that the quantum vacuum is not really nothing, or that the question is malformed, or that science will get to it eventually. What you will not receive is an answer, because the question is not a scientific question at all. It is a question about why there is a domain for science to study. And that question stands outside the system, exactly where a description can never reach. There is one last move the materialist will make here, and it deserves a direct response, because it is the most common move of all. Told that the physics is incomplete, that the holographic principle is unformulated, that the information paradox is unsolved, the reply comes back, yes, but science will figure it out. Give it time. Every gap has eventually been filled. This one will be too. Have a little faith in the method. Look closely at what that sentence actually is. Science will explain it eventually is not an argument. It is a promissory note written against a bank account no one has opened. It is faith. Faith in future discoveries that may never come, deployed precisely at the moment the present evidence points somewhere uncomfortable. And notice the double standard. When a believer points to a gap and infers a cause beyond the physical, the materialist calls it God of the gaps and dismisses it. But when the materialist points to the very same gap and inserts a confident I owe you, naturalism will close this, trust me. That is supposed to be sober science. It is the identical logical move. A gap and an act of faith about what fills it. The only difference is the direction of the faith. And here is the asymmetry that actually matters. The evidence for an intelligent cause is not a gap. It is a presence. It is the fine-tuning that is measured right now, the order that is observed right now, the impossibility of something from nothing that holds right now. The theist is not saying we cannot explain this, therefore God. The theist is saying that this, the order, the precision, the contingent existence of a structured world, is itself the evidence, and it is on the table today. The materialist's confidence rests on discoveries not yet made. The theist's conclusion rests on the universe as it actually is. One of these is a faith about tomorrow. The other is an inference from what is in front of us tonight. That brings us to the second great claim, the one that gives this exploration its title: the block universe. Time does not pass. The future already exists. Scri-Plus is the finished back cover, proving the whole book was always written. Therefore, the argument continues, there is no genuine becoming, no real freedom, no open future, and no need for anything to bring the next moment into being, because there is no next moment. It is all simply there. Again, let us give it its strongest form, and then let us test it. The case for the block universe rests almost entirely on one pillar: the relativity of simultaneity in Einstein's special relativity. Different observers disagree about what is happening now far away. Therefore, the eternalist concludes, there is no objective now, and all moments are equally real. Einstein's own words to the Besso family are quoted like scripture. The conclusion feels as though it descends straight from the equations. But here is what is almost never said aloud. The block universe is not a result of relativity. It is an interpretation of relativity, a philosophical choice laid on top of the physics, not squeezed out of it. And we know this for certain because there exist alternative formulations, fully consistent with every experimental prediction relativity has ever made, that do not require a static block at all. Physicists and philosophers have built models in which time is physically real and fundamental. Lee Smolin has argued for exactly this in his work on the reality of time. Others have shown that the supposed leap from observers disagree about now to the future already exists simply does not follow logically. The relativity of simultaneity tells you that simultaneity is frame-dependent. It does not tell you that the future is real. That second step is a metaphysical addition, and it can be declined without contradicting a single measurement. Notice the move that has been made, because it is the same move as before. A piece of genuine physics, the relativity of simultaneity, solid and tested and true, has been used as a vehicle to smuggle in a much larger philosophical cargo. The unreality of time, the fixity of the future, the absence of becoming. The physics is the Trojan horse. The philosophy is the army hidden inside it. And once you see the smuggling, you can refuse delivery. You can accept all of relativity, every last equation, and still hold that time is real, that the future is open, that becoming is genuine. Physics does not forbid it. Physics is silent on it. And there is a deeper incoherence in the eternalist position, one that turns the argument against itself. Block universe says the passage of time is an illusion. But an illusion is something that happens. It is an event in consciousness, a thing that occurs and is then succeeded by the next thing. To call the flow of time an illusion is already to assume the very flow you are trying to deny. The illusion of passage would itself have to pass. If nothing ever becomes, then the illusion of becoming never becomes either. And then there is no illusion to point to, and the explanation collapses. The eternalist is in the position of a man who insists at great length and in a specific order, word after word, that nothing ever happens in a specific order. The structure of his own argument refutes its content. What does it mean that the most powerful evidence for the block universe is a feeling we are told to distrust, the feeling of the present moment? And yet, that feeling is the one thing none of us can actually do without, not even for the length of a sentence. And here is the point that matters most for where we have been. Suppose the eternalist were entirely right. Suppose the universe is a finished block, complete from the first instant to the boundary at Scri-Plus. Every moment equally real, the whole of history laid out and unchanging. Does that remove the need for an explanation? It does precisely the opposite. A finished, timeless, perfectly structured four-dimensional object is not less in need of an explanation than an unfolding one. It is more. Now you do not merely have the question of why each moment follows the last. You have the staggering question of why this entire, intricate, complete structure exists at all, fully formed, rather than nothing. A block universe does not explain itself any more than a book explains why it was written. A finished book, sitting closed on a shelf, complete in every word, still had an author. Completeness does not remove the need for a cause, it sharpens it. The more perfectly finished the structure, the more insistently it points beyond itself to whatever set it down. Which brings us to the third claim, and to the most precise piece of evidence this entire subject has to offer. Remember the loose thread we left hanging long ago, the infinite degeneracy of the vacuum. Empty space, we said, is not unique. There are infinitely many distinct vacua related by supertranslations, and the universe had to settle into one of them. Remember, too, that the whole arrow of time, the whole one-way flow of energy and radiation outward towards Scri-Plus, depends on the universe having begun in a very particular, very low entropy state. Light streams to the future boundary, and not from it, only because the beginning was exquisitely ordered. So, here is the question the materialist must face. Why this beginning? Why this vacuum, this ordering, this initial condition, out of the unimaginable number of alternatives? The standard answer is no reason. It is a brute fact, or it is anthropic selection across a multiverse. Somewhere in an endless landscape of universes, every possible initial condition is realized, and we naturally find ourselves in one of the rare ones that permits observers. No designer needed, just chance, and enough universes to make even the most absurd luck inevitable. Now let us look hard at exactly how absurd the luck has to be. The man who calculated it was Roger Penrose, the same Penrose who first taught us to draw Scri-Plus, the same man whose conformal diagrams underlie this entire story. Penrose asked how precisely the initial state of the universe had to be tuned to produce the ordered cosmos we observe, with its reliable arrow of time. The answer he arrived at is a number that breaks the mind. The probability, he found, was 1 part in 10 to the power of 10 to the power of 123. Let me try to convey what that means, though I warn you in advance that it cannot really be done. Penrose himself pointed out that you could not even write the number down. If you tried to print it in full, a 1 followed by all its zeros, and you wrote a 0 on every single particle in the observable universe, you would run out of particles long before you ran out of zeros. The number of zeros alone exceeds the number of things in existence. This is not a long shot. This is not a 1 in a billion fluke. It is a precision so total that the word improbable buckles under it. Picture a combination lock. Not an ordinary one, but a lock with a vast bank of dials, each dial running not from 0 to 9, but from 0 to a number too large to name. The universe is a lock like that, and it opened. Every dial, the initial entropy, the selected vacuum, the constants that ride along with them, sits at exactly the value required for a cosmos that can hold stars and chemistry and minds capable of asking why. Set any dial slightly differently, and there is no one here to notice. And here is the part that should stop you cold. The dials were not turned by any hand we can see. They came preset. From the very first instant, before there was a single star, the combination was already entered, already correct, already permitting everything that would follow. What does it mean that the universe began with its combination already dialed to a precision of 1 part in 10 to the 10 to the 123? The materialist has exactly one escape from this, and it is the multiverse. If there are enough universes, then somewhere the lock opens by chance, and that somewhere is us. But examine what this escape actually costs. There is no evidence, none, for a single other universe. Not one has ever been observed, measured, or detected, and, by the nature of the proposal, not one ever could be. The multiverse is invoked for precisely one reason: to make a number this devastating go away. And it does not even succeed on its own terms, because the machinery that would generate all those universes, the inflating landscape, the mechanism spawning world after world, would itself have to be exquisitely structured, exquisitely tuned to do the spawning. You have not removed the fine-tuning, you have pushed it up one level and hidden it behind a curtain no one is allowed to look behind. Cosmologists even have a name for the deepest technical wound in this program: the measure problem. The inability to so much as define probabilities across infinite universes in a consistent way. And it has been called, by serious people, one of the greatest crises in physics. And now watch the inversion, because it is exact and it is fatal. For decades, materialists have accused believers of invoking a god of the gaps, of reaching for a creator wherever science has not yet filled in the details. But what is the multiverse? It is an unobservable, untestable, infinitely multiplied entity, conjured into existence for the sole purpose of explaining away evidence that points somewhere uncomfortable. It is naturalism of the gaps. It is the same move it claims to despise, wearing a lab coat. When the evidence points toward design, and your response is to postulate infinite, invisible universes rather than accept the inference, you have not been more scientific than the theist. You have been less. You have abandoned the one universe you can actually study in favor of an infinity of universes you invented precisely because they can never be checked. What does it mean that the only way to escape the evidence for design is to conjure an endless multitude of worlds no instrument could ever detect? Here is what makes this argument different from 1,000 vague gestures at cosmic wonder. It is specific. It is on topic. The very boundary structure we have spent this whole exploration studying, the low entropy beginning that orients all light towards Scri-Plus, the selected vacuum among infinitely many, is the exact thing carrying this quantified, monstrous improbability. The fine-tuning is not bolted on from outside. It lives in the foundations of the subject itself. And it was measured, let me remind you, by an atheist. Penrose does not believe in God. He looked at his own number, 1 in 10 to the 10 to the 123, and rather than infer a tuner, he proposed that some unknown, very special physical constraint must have governed the beginning. But notice what he could not bring himself to say. He could not say it was an accident. The number forbids it. He felt the force of it. He reached for a very special constraint, a something, anything, to account for a precision that chance cannot touch. The believer follows that same evidence one honest step further and asks what kind of something selects from an infinity of possibilities exactly the one that yields a universe like ours. Selection from alternatives is not the work of unconscious matter. It is the signature of will. Let me bring all of this down out of the mathematics and into a life. Yours. Think of a single human life as a story being written. Each day, another page. Each choice, another line. Now imagine that at the end of that life, every page exists at once, the whole book complete, your first word and your last breath equally real, bound together in a single volume. That is the block universe applied to you. And in one sense, it is a comforting image. Nothing is truly lost. The day you were happiest is not gone. It simply is, eternally, at its place in the book. The people you have lost are not erased. Their pages remain exactly as written. This is the everyday picture the eternalist offers, and you can feel why it consoles. But follow the analogy to where it breaks, because the place it breaks is the place the truth lives. A book that is complete, that exists all at once, every page already written, did not write itself. The more finished it is, the more obviously it required an author. You cannot point to a closed, complete, perfectly ordered volume and say, "You see, there was no writer. Look how whole it is." Its wholeness is the very thing that screams of a writer. And so, the block universe, offered as proof that no author is needed, proves the opposite the moment you take it seriously. If your life is a finished book, then someone wrote it. If the cosmos is a finished block, complete from its low entropy first page to its final boundary at Scri-Plus, then the completeness does not banish the author, it reveals him. The analogy consoles only as long as you do not ask the one question that matters. Who set down the pages? The instant you ask it, the comfortable picture turns and points beyond itself. So let us gather what the evidence actually shows, examined honestly with nothing assumed. We have a universe whose physics, by the open admission of its own architects, is not complete, whose central organizing principle cannot yet even be formulated for the world we live in. We have a description that, even if completed, could never explain why there is anything to describe, because a law is not a cause, and a blueprint is not a builder. We have a block of space-time which, the more perfectly finished it is claimed to be, the more loudly it demands an author for its existence. And we have a beginning, tuned to a precision of one part in a number we cannot even write, a precision that chance cannot reach, that the multiverse can only hide rather than explain, and that even an atheist who measured it could not call an accident. 4 lines of evidence. They do not point in 4 directions, they converge. They point, every one of them, past the edge of the physical, toward a cause that is not itself a part of the universe. A cause that exists independently of the space-time it grounds, that possesses the knowledge written into the universe's every constant, and that possesses the will to select this world from the infinite alternatives that were never chosen. Power to bring it into being, knowledge to structure it, will to choose it. These are not the properties of unconscious matter. Matter selects nothing, knows nothing, intends nothing. These are the properties of a mind. The evidence, followed without flinching, does not end in equations. It ends in an intelligent cause. Let me bring this exploration to a close. We began with a single ray of light and the simple, impossible question of where it goes. We followed it to the edge of space-time, to Scri-Plus, future null infinity, the boundary Roger Penrose first taught us to draw, where every photon that has ever existed is bound and will, in the fullness of forever, arrive. We found that edge was not empty. We found the infinite symmetry of the BMS group living there, and the super translations that make empty space infinitely many. We found the Bondi-Sachs formula that turns 3 vanished suns into a ripple, and the permanent memory those ripples leave scarred into the space of your own body. We found soft hair and the holographic plate, and the staggering proposal of celestial holography, that a 4-dimensional universe might be written whole on a 2-dimensional sky. And we found the block universe, and the claim that Scri-Plus is the boundary where it ends, the finished back cover of a book that was always already written. And then we tested the larger story that had been wrapped around that beautiful physics. We found that the claim of a self-explaining, creatorless universe rests on a principle its own founders admit is unformulated, a mechanism its critics show is irrelevant, and a confusion between describing a thing and explaining why it exists. We found that the block universe, far from removing the need for an author, demands one all the more insistently, the more complete it is said to be. And we found, at the very foundation of the subject, a fine-tuning so precise that the man who measured it, an unbeliever, could not bring himself to call it chance. The mathematics of Scri-Plus is some of the most beautiful in all of physics, and none of it is threatened by anything I have said. The physics stands. What does not stand is the quiet assumption that the physics is all there is, that a complete record needs no record keeper, that a finished book needs no author, that a combination dialed to impossible precision turned its own dials. Strip that assumption away, follow the evidence where it actually leads, and the universe does not look like an accident that explains itself. It looks like something made. If you found value in this exploration, consider subscribing. It helps these deep dives reach more curious minds. There is one thread we touched tonight, but never fully unspooled. The idea that the universe keeps a perfect and permanent record of every event that has ever happened, written onto a boundary no observer can ever stand at to read. We met it here as the holographic plate, almost in passing. But that single idea, a cosmos that forgets nothing, that stores the complete history of all things, opens a door far wider than this one video could pass through. I have followed it much further elsewhere. If the thought of a universe that keeps every record has lodged itself in you, you will find where that path continues on the end screen now, and in the description below. Every light that has ever shone is still traveling, even now, toward the edge of everything. The record is being written, patiently and permanently, on a surface at the end of time that none of us will ever reach. Perhaps that is the loneliest fact in physics, that the universe keeps so perfect an account and that no one within it can ever read the final page. Or perhaps it is the most hopeful, because a record so complete, kept so faithfully, where no created eye will ever see it, suggests that it was never being written for us. It suggests that someone else is reading. Good night.